Alright, you guys, this is our very last video, well, of the whole school year. That's pretty sweet, huh? So, on this one, all we're going to do, this is just one quick problem solving type, is to solve for when you have a series and parallel circuit that's combined. So there's parts of it that's in series, parts of it in parallel. There's a lot of questions that you could be asked with that. The kind of question that you're going to be looking for from me is just to find the total resistance of the whole system. You have this whole problem solving strategy in your notes. You can read over that. But in essence, all we're trying to do here is to find the most complicated part of the circuit and reduce it using the rules for finding the resistance in parallel and series. And you just keep reducing it and reducing it and reducing it until you've completely simplified the circuit and you just have one resistor and its total resistance. So here's an example of what I'm talking about. So here's your combination circuit example. So this is more complicated than what we've been looking at, but compared to a real circuit, it's actually pretty simple. So when I start by looking at the most complicated part of the circuit, and here to me that probably this part up here looks like it's the most complicated. So first I see that 1 and 5, they're together in series, so I can find the equivalent resistance just for that branch. So I use my rules for series, which means I just add them up, and I say that section has a resistance of 6 ohms. So what you're going to see me do on this video is then replace that branch, the 1 and the 5, with 6 ohms. You don't have to do that. You could just write 6 next to it if you'd like, whatever's going to help you keep track of it. But it might be annoying if you have to redraw the whole thing. But mine, look at that, is pretty and redrawn. So that whole branch now is 6. So what I have now is I have two sections in parallel. So this is a little complicated and this section's a little complicated. So I'm going to simplify both of those on this slide. So for the top one then, I'm going to use the rules for parallel circuits. And I know that's the 1 over equation, right? So I find that equivalent resistance is 3 ohms. On the bottom, same thing, that's in parallel. I use the 4 and the 12, the inverse of those equals the inverse of the equivalent resistance, and I find that the total resistance for that branch is 3 ohms. So again, I'm going to replace my red circles with my new resistances. You can just make a note next to it if you would like. Ta-da! See, now my circuit is looking more and more simplified, which is kind of cool because now I look at that and that's pretty easy. I've got 3 and 3 at the top in series and I've got 3 and 9 at the bottom in series. So to find the equivalent resistance for those, I just add them up and now I have 6 and 12. So here's my 6 and 12. And I can see that those two are in parallel with each other. So I circle both of them, and I use my rules for parallel circuits to find the equivalent resistance of that whole thing is just 4 ohms. So now that's looking good. Now that's a circuit I don't mind solving. 4 plus 3, 7. And I do have one more slide. Okay, that's just silly. But if I simplify that whole thing then, it starts out all complicated using the rules for series and parallel, the resistance for resistance rules. I can find the equivalent resistance for the entire circuit. So that's a method of how you would do that. You just have to be very methodical about it and make sure you don't, skip a branch. So the equivalent resistance for this whole thing is 7. Nice, easy peasy. That's it. That's it for the whole year. Woohoo! Happy dance.